Hello everyone, I am Dr. Nitin Kumar Saxena. In my previous video, I have discussed the concepts of electrostatic potential energy difference, potential difference and potential. And I have given you the mathematical expression for getting the value of electrostatic potential. In this video, we will try to find the expressions when the electrons that when the we have the different kinds of the charge characteristics, like we have studied electric dipole. So if we have an electric dipole in space, electric dipole means 1 plus q charge, 1 minus q charge, which is placed at a very short distance. So what would be the value of electrostatic potential at any point in space? What will happen if we have number of charges which is placed in space and at particular point? What would be the value of potential and how can we find it? And finally, if in place of point charge we have a realistic surface having the charge which is called continuous charge distribution, then how can we find the value of electrostatic potential? So to see this, let us begin with the first topic. The first topic is that what would be the value of electrostatic potential due to an electric dipole? Okay, so let us start by its drawing by its figure. Suppose I am saying I have a plus q charge particle which is placed at point A and minus q charge particle placed at point B, right? And the center of the dipole is O, right? The center of the dipole is O. Suppose the total distance of between plus q and minus q charges A in such a way that the center distance from plus q is A, the center point from minus q is A. This is fine. And in general, we have any point P like this. So the question is, find the value of potential at point P due to this electric dipole. Okay, so how can we start it? So before starting, I'm again revising the concept of electric dipole. If I am saying this is minus q and this plus q, so the direction of electric dipole will be P and the value of P will be q into 2a, right? And the direction of P is from negative charge to plus charge. Now, please draw a line from B to P and a line from A to P and a line from O to P. Is it okay? Suppose I am saying this distance is R2, this distance is R1 and this distance is R, right? So the distance of the point P from the center of dipole is R. The distance of point P from this negative charge is R2. The distance of point P from this plus q charge is R1. Okay. So you see here what I can write. I can write in a way that what is the value at point P, the potential, electrostatic potential value. So at P due to A, at P due to A, we have the formula 1 upon 4 pi epsilon naught. This formula we have seen in my previous video. Q upon R1. Is it fine? So the potential, electrostatic potential at point P due to the plus Q is given by this formula, right? Similarly, the value of potential at P due to B is given by 1 upon 4 pi epsilon Q upon R2. But since it is a negative charge, so we will take it in negative, right? So the total voltage, the total potential at point P is given by VPA minus VP, plus. Why? Because this potential is a scalar quantity and we have the two potentials at point P. One is VPA, second is VPV. So if we want to know the total value of potential at point P, what we will do? We will simply add it. Okay, so you see here, when you will solve this, and I am putting Q common here, so what you will get? 1 upon R1 minus 1 upon R2. So this will be the value of potential at point P due to the dipole plus Q and minus Q. Now normally we define the distance from the center of the dipole, which is R. So what we have to do, this formula is okay, but we want to know the formula in terms of this R rather than R1 and R2. So for doing this, we have to do some mathematical manipulations with this formula. So let us start with assuming that, okay, I am saying this angle is theta. This angle is theta. So if this angle is theta, so you see you have, I'm quickly revising your mathematical formula, that cos A is given by B square plus C square minus A square upon 2BC for any triangle. Suppose I am saying this is angle A, this is A, this is B, and this C. So the angle between the sides B and C can be written by this formula. The same approach I am using here. So if I am using the same approach, so what can I say? I can say, yes, theta is between this A, because this is OA is A and this is R. So cos theta is A square plus R square minus R1 square upon 2AR. This is fine. So when I will solve this, I will get R1 square is A square plus R square minus 2AR cos theta. This is okay. This is okay. Now, same approach, the same thing you can use here. If I am saying this angle is theta, so what is left here? This would be pi minus theta, right? So again I can write for this triangle, pi minus theta is the angle between this and this. So cos pi minus theta is given by A square plus R square minus R2 square divided by 2AR. And since cos pi minus theta is a minus cos theta, and then you will solve this, you will get R2 square is A square plus R square plus 2AR cos theta. This is clear? If this is clear, so again you do one thing. what you can do, like you take the first expression r1 square and take r square common here. So what you will get? 1 plus a square upon r square minus 2a cos theta upon r. This is okay. What I am doing? I am taking r square common here. So when I am taking r square common, so this is 1. A square upon r square will come here. Minus 2ar cos theta divided by r square. So what will happen? 1r will cancel with 1r. So 2a cos theta upon r. Right? Now, since you know the distance between the charged particle plus q and minus q is very small, the length of the dipole is very small, so this means that A is very less with r. If A is very less with r, so what we can do? We can neglect this term. We can neglect this term. So if we are neglecting this term, and on neglecting, what I will get? I will get something r1 square 1 minus 2a cos theta upon r. Right? Now, again, after neglecting this, finally you see I want 1 upon r1. So what I can do? I can make the whole expression like this. Okay, I am writing it here for your convenience. What I am saying, finally I want 1 upon r1. And this is r1 square. So if I divide the whole expression by 1, so I can write like this: 1 upon r1 square is 1 upon r square into 1 upon 1 minus 2a cos theta upon r. This is okay. And next step, since I want 1 upon r1, so I can take the square root of the whole expression. So if I take the square of the whole expression, so what can I do? Let me allow to solve this here. So this will be 1 upon r1 is 1 upon r, 1 upon r1 is 1 upon r into 1 upon 1 minus 2a cos theta upon r, the whole power is 1 by 2. This is fine. So taking the square root both the side, so 1 minus 2a cos theta upon r will be square root and the power is half. You see, I can write it again 1 upon r. I can bring this expression, in upside, means to numerator. So what will happen? 1 minus 2a cos theta upon r, the whole power is 1 minus 1 by 2. So finally, what I am getting here now? So I am getting that 1 upon r1 is 1 upon r 1 minus 2a cos theta upon r, the whole power is minus 1 by 2. And again the assumption is taken with the help of binomial expression. If you know, so I am writing it again here for your convenience. 1 plus x power n can be approximately written as 1 plus nx. This is the concept which I am using from the expansion of binomial. Okay, so 1 plus x power n can be written as 1 plus nx. So what I will do here, 1 upon r, when minus 1 by 2 will come inside, so minus and minus plus, 2 will be cancelled with 2a, 2. So a cos theta upon r. Okay. So in simple word, I can say that yes, 1 upon r1 can be written as 1 by r, 1 plus a cos theta by r. I hope this concept is clear to you. Simply I am using some mathematics, and by mathematics I am trying to find the value of 1 upon r1, because it here is 1 upon r1. I am trying to find the value of 1 upon r1 in terms of r, a and cos theta. Right. In the same way, if I'll solve for r2, so I am giving you direct expression. This will be 1 minus a cos theta upon r. Same concept you will apply. You will first, you will take the r1 to r2 square, then you will take inverse of 1 upon r2 square, and so then this term, you will take r square common from this, and after taking r square from this, you like neglect the term a square upon r square, and after that you take the binomial expansion, and finally when you will see, then you will get this expression. Okay, so now you have the expression of 1 upon r1 and you have the expression of 1 upon r2. So simply in next step you put the value of 1 upon r1 and 1 upon r2 in this. So what you will get? Vp is q upon 4 pi epsilon naught. 1 upon r1 is 1 upon r 1 plus a cos theta upon r minus 1 upon r 1 minus a cos theta upon r. Right? Again you see, you can take 1 by r common from here. So if you take 1 by r common, so what will happen? So if you take this common, so Vp can be given as 1 upon 4 pi epsilon naught q upon r, q upon r common, and inside the bracket 1 plus a cos theta upon r minus 1 plus a cos theta on r. Solve this. So 1 upon 4 pi epsilon naught q upon r. This 1 and 1 is cancelled again. So you got 2a cos theta upon r. Okay. So 1 upon 4 pi epsilon naught. You see here what will happen? This will be r square, and q into 2a is p. So I can write p cos theta. So what can I write? We can write p cos theta. So this is the final expression for Bp, that Bp is given by 1 upon 4 pi epsilon naught p cos theta divided by r square. What is theta? You see, theta is the angle which it makes from this is the direction of p. You see, this is the direction of p, and see, this is the direction of r. So in other words, I can say that theta is the angle between P and R. Okay, the theta is the angle between P and R. The direction of P I know, the direction of R I know. So, and in other words, I can also write like this, that P into R cap. So when you will solve P dot R cap, what you will get? P into mod of P into mod of R cap into cos theta. So what is the mod of P? Is P, the value of this is a cap, so 1 P cos theta. So this means Vp can be written as 1 upon 4 pi epsilon naught. P cos theta can be written as P cap, sorry, P vector into R cap, and they have the dot product, right? Divided by R square. So either you can write the value of potential due to this dipole at point P by this formula or by this formula. Both the formula are correct, right? Now you see the special cases. What are the special cases? Special case means when this point P, is on the axis of the dipole, right? And second case, when the point P is at the line which is going from the midpoint of the dipole and perpendicular to this dipole. That we have already done in chapter 1 for electric field due to dipole. The same thing I am repeating here for the potential value. So for first case, when I am saying this point is going in this direction, so what will happen? If you see this point P is going on this line, then first case, let me allow, when P is in the axis of dipole. Number 2, when P is at equatorial plane of dipole. Right? So in first case, you see the value of theta will be, in first case, the value of theta will be 0. So when you put theta equals to 0, so cos 0 is 1, then Vp will be 1 upon 4 pi epsilon naught P upon R square. P upon R square. And in second case, theta will be 90 degree. So the value of Vp will be 0. Right? So I hope the concept of potential at dipole is clear to you, and you see the difference. One more thing I want to emphasize here is that at electric potential due to point charge I want to know the value of electric potential at point P. So if I am considering only a point charge, then Vp is proportional to the value of, inversely proportional to the value of R. By due to electric dipole, Vp is proportional to, you see the formula we have in denominator R square. So if we are considering only point charge, the electric potential is inversely proportional to R. For dipole, it is inversely proportional to the square of the distance, right? So this also you have to keep in mind. Then next point is like third point. Okay, we can say if I have like number of charges mean to say, suppose I have, suppose q1, q2, q3, q4. Suppose this is minus, this is also minus, this is plus, and this is plus, and this is the point P, right? So what is the question? The question is, we have four charged particles. These all are point charges, q1, q2, q3 and q4. q1 and q3 are negative while q2 and q4 are positive. Now due to these four charged particles, you know all these charged particles will produce their own electric field, and therefore at point P we have four different electric field due to 1, 2, 3, 4. So the overall value of electric potential at point P can be given as the value of electric potential at P is given as the algebraic sum of the potential by this is clear. What I wrote, okay, I am writing again. So the value of potential at P is given by algebraic sum of the voltage at P due to, let me write first and I'll explain. Okay. So what is this? You see that the total potential at point P will be the sum of the potential by individual J may be from 1 to n. So P1, then P2, then P3, then P4 and so on up to the point n. So Vn. And we are taking the algebraic sum. So what we will do, since potential is a scalar quantity, so we will try to find the value of potential at point P due to 1, due to 2, due to 3, due to 4, and we will add them algebraically. And when we will add them, we will find the overall value of potential of electric potential at point P. So for this particular problem, if I draw, so what can I write for this particular problem? You can write, okay, so this is the most general formula, and for this particular problem we will say as Vp is Vp due to 1, Vp due to 2, Vp due to 3, Vp due to 4. And if I write this in this form, so you see J is 1, 2, 3, 4. So J will go from 1 to 4. Vp1, Vp2, Vp3, Vp4, and we will write that we will get like this. Okay, so 1 upon 4 pi epsilon naught Q1 upon, suppose this is R1 plus, this is negative, so I will take negative side. 1 upon 4 pi epsilon naught Q2 upon R2, 1 upon 4 pi epsilon naught minus Q3 upon R3, 1 upon 4 pi epsilon naught Q4 upon R. So when we will solve this, we will get the overall value of potential at point P. Is it clear? So I hope the concept of multiple charges placed in space is clear to you. And now the last topic is the potential due to a continuous charge distribution. The last topic is potential due to a continuous charge. Potential due to a continuous charge distribution. Okay, in the previous chapter, we have seen that if we have continuous charge distribution, it may be one dimensional, two dimensional, or three dimensional. So for one dimensional, we use